Applying theorems about isometries and identifying and drawing compositions, transformations, and glide reflections are the objectives for this particular lesson. So what is a composition of transformations? A composition of transformations is actually just one transformation followed by another. So for example, if I tell you to reflect and then let's say translate a particular figure, those two together would be a composition of translations. So you would take a figure like this heart, and I would say first reflect it over the line, so it's been reflected, and now translate it, so you could translate it, say in this direction. So this here is your pre-image. And then after you have done the composition of transformations, you end up here with your image. And that's it. It's just one transformation followed by another. Now, one thing you notice about the transformations when you do a composition of transformations, it is an isometry. Even though you're doing two different transformations from the pre-image to an image, the size and shape remain the same. So let's do a 180-degree rotation followed by a reflection over the y-axis for this particular figure. So I'm going to do the first K, which is 4. I'm going to do 4, 2. So 4, 2. And then L, 5, negative 2. And then M, 1, negative 4. Okay, so there is our original pre-image, and I'm going to do K, L, and M. Now the very first thing we have to do is rotate it 180 degrees. So K prime is going to be negative 4, negative 2. L prime is going to be negative 5, 2. And M prime is going to be negative 1, 4. So I'm going to do that in a different color. So we've got negative 4, negative 2. That's K prime. And then negative 5, 2. And then negative 1, 4. So there is our first figure, and that's been rotated 180 degrees about the origin. I don't want to leave the dot there. It looks like it's part of the picture. Now I have to reflect it over the y-axis. So I'm going to call these new image points K double prime. So let's see here. We've got K double prime, which takes these and reflect them over the y-axis, which means all the x values become negative. So it would be 4, negative 2. L double prime would be 5, 2. And M double prime would be 1, 4. So our final image is going to be 4, negative 2. And then 5, 2. It's right there, and then 1, 4 is here. So we've done an 180-degree rotation and a reflection over the y-axis, and so that is the last image that we drew there. Okay, a glide reflection is just a composition where first you glide it, you translate the image, and then you reflect it. So as you can see for this triangle JKL, first you translate it in this direction, the length of the vector, so that's the first translation of the pre-image, and then you reflect it across the line L, and then this new image that you have is a glide reflection of the original. Now, you can do a composition of reflections over parallel lines. So let's say we start with an image. We've got this parallelogram here. What we're going to do is do two reflections over these two lines that are parallel. So the first time we reflect it, we get that. Now these two, this is the first and that's the second. This is the prime image and this is the original, the pre-image. And now we're going to take our second image and we're going to reflect that over another parallel line. And there's that reflection. Now notice, what's the relationship between our pre-image and our final image after it has undergone two reflections over parallel lines? Just think about that for a second. What's the relationship between the pre-image and the image? So here we have just that. We have the conclusion of what that is. The composition of two reflections over parallel lines is equivalent to a translation. The translation vector is perpendicular to the lines that it was reflected over. So here's our translation vector. And the other thing is that the length of the translation vector is twice the distance between the two lines. So if you measure the distance between these two lines and then you double it, that's how far you went from the pre-image to the image. Now what happens when we try to reflect an image over two intersecting lines? The lines are no longer parallel. Well, there's our first image, or that's the pre-image, excuse me, and we're going to reflect the pre-image over this first line. So there's our reflection. Now we have to reflect this image here over our second line, and the two lines are intersecting. So that's what we get. So again, what's the relationship between the pre-image and the image? What's the relationship between those two when you reflect an image over two intersecting lines? The relationship is that when you have a composition of reflections over two intersecting lines, it's equivalent to a rotation of the original pre-image. The center of rotation is where the intersection of the two lines are, and the angle of rotation is twice the angle that's formed by the two lines. So if this angle was 30 degrees, then the rotation from blue to red would be a 60-degree rotation about the point of about that point, which is the intersection of the two lines. All right, so rewatch any parts of the video, make sure you understand it fully. If you're watching on YouTube, please be sure to type any questions you have, and you know what we're going to do in class tomorrow. See you then.